Okay, so we will be talking about certain mechanisms. You have a manually operated can crusher here, as you see. It's operated by hand, and you put a can in between these two parts, and when you hold it down, it crushes that can. One is the ground link, second is the thing that you operate manually, the third one is the connecting link, and the fourth one is the crusher. Okay, this is a very basic mechanism. This is a simple press. This has 6 links, as you see, and one is the ground. Usually the ground is the fixed link, by the way, and we count ground as one link in mechanisms. That's one of the important things. Every mechanism has to be connected somehow to the ground, and that is called, you term the link 1 usually. The rest of the links are the other links. For example, this is the second link, third link, fourth link, fifth, and the sixth one is again a piston that presses. It crushes something. I don't know what, but this is a commonly used manual press, for example. This is used in machinery. And here is a window wiper. It is a rear window wiper, means the backward window. It is a 3-dimensional mechanism. Actually, it is a 3-dimensional 4-bar mechanism. It is a 4-bar. The fourth one is a prismatic link. Well, it is a piston. We don't call it prismatic link. It is called a prismatic. There is a prismatic joint between link 1 and link 4. You don't have a prismatic link. You have a sliding link or a piston link. But the joint between link 1, which is the ground, and the 4 here in the can crusher, I mean, between 1 and 4, you have a prismatic joint, okay? The prismatic connection. So these are very basic mechanisms, as we see. Again, you have 4 links. 1 is the ground, 2 is the crank, the third one is the connector, and the fourth one is the windshield, sorry, not the windshield. It is the wiper that wipes the windshield. It moves back and forth like this so that it cleans the back window, for example. Here you have another machine that has a crank. Let me see. The ground is the first link. The first link is the ground. The second link is connected to a motor, and it rotates continuously, as you see. The third one is a connecting rod. The fourth one is this thing that moves back and forth again. The fifth one connects the prismatic, well, not the link, but connects to the prismatic joint, let's say. And the sixth one moves back and forth. What does it do? You have a package here. It pushes the package to the conveyor and then comes back. Then another package comes, it pushes that package to the conveyor and so on. Do you understand? So it is a mechanism that moves packages from an assembly bench to a conveyor. And this is a very commonly used mechanism. The second link, as you see, rotates continuously. And the sixth link moves back and forth like this and moves the packages that comes in front of it to the conveyor. And if you go to a factory, you will always see things like mechanisms like these inside machines. This is another mechanism. It's a 6-link mechanism, 6-bar mechanism, in which you have a hydraulic piston. As you see, the actuator is a hydraulic piston. Between links 2 and 3, this one, you have a hydraulic piston. So what does this thing do? It basically moves a box, let's say. Well, fifth is this thing. From one platform, this one at the top, let's say, to the one at the bottom. So that this motion, it takes the box from the, let's say, upper end and moves it towards the lower end. So it's a lift platform. And this is another 6-bar mechanism. It carries a microwave oven from one location to another one. I don't know why it is called assist people on a wheelchair. I have no idea why I have put there. Anyway, this is a lift platform, for example, again used in a truck. This is another mechanism. Sorry. And this is another mechanism. This mechanism closes the flap of the boxes, as you see. Again, you have a machine that is rotating, a motor that is rotating. And that motion is converted to this kind of back and forth motion like this that closes the top flap of the boxes. So it's an interesting device. This device, this mechanism climbs the stairs by help of a motor. So it is designed to climb the stairs. And here you have a box. This is a silly toy, actually. When you press the switch by hand, the mechanism makes a motion and then presses that switch and closes itself off. So it's a machine that automatically turns itself off. It's it's a joke. It is just meant to be a joke, actually, but it's interesting. This is a mechanism used for airplane landing. In the first 6-bar mechanism, Ilker asks, in the first 6-bar mechanism, why didn't we consider the ground that 4th bar is connected as a joint? Let's see. Well, ground is a link, it's not a joint, but let's go back and answer that. You mean this one? Next. Okay, you mean this one. This one. Okay. So you say that the 4th link is connected to the ground. Ground is always the ground. The 4th link is connected to, all the ground is link 1. This is link 1. Can you see my cursor, by the way?
Yes, hocam.
Okay, so this is link 1, this is link 1, this is link 1, everything is link 1 here. Ground is the thing that doesn't move is link 1. The others are moving with respect to the ground. So the 4th link is moving with respect to the ground, okay? So you don't have a ground here and another ground here. All of them is ground and it is all one link. Do you understand? Ilker, do you understand? Okay. So let's go on. So this is complicated and it's not very easy to understand, but it's made up of some hydraulics and it's a certain mechanism. This is an exercise machine in which the person uses rowing. It is again an exercise machine, which is made up of a mechanism, as you see. And here you have a prosthetic knee mechanism for people with injuries. If you have a fractured knee or something, you can, design a mechanism to replace that knee. Obviously, it's a complicated mechanism. I don't know the details of it, but as you see, it can be inserted in place of that, let's say, fractured knee, so that it can be used for that purpose. And there are certain categories of mechanisms. They are divided into categories. So there are, for example, function generating mechanisms in which output is a function of the input. There are motion mechanisms so that the object is oriented inside with respect to the mechanism. I'll give you examples. For example, let's say the computer screen or something, so that you can hide the computer screen and turn it on. And then there are the path generating mechanisms. Let's try to look at that. For example, you have a wheelchair brake mechanism. Here the wheelchair, as you see, wheelchair is this thing, whole thing. The small thing over here is the 4-bar mechanism. In this position, the brake does not touch the wheel. Therefore, the wheelchair is free to move. But when you push this, hand lock, this mechanism comes to the following position, and then the brake engages with the wheel, and the wheel does not move. So it is basically a 4-bar mechanism. The small thing over here is a 4-bar mechanism, as you see. Again, a 4-bar mechanism, which is a lawn sprinkler. Lawn sprinkler means when you have a lawn, you water it, but the water has to, you have to move the water all around the lawn. Çim sulayıcı in Turkish, that is. So this input link, which is connected to a motor, is again, it's a 4-bar mechanism whose dimensions are adjustable by this clamping screw, so that this thing, sprinkler, moves back and forth in order to water the lawn, for example. Okay, another 4-bar mechanism used in the automobile hood. As you see, the one is the frame of the automobile, 3 is the hood, the link 3 is connected to the hood, 2 is the connecting rod, and the 4th one is another link. Basically, this hood opens and stays there by the help of some sort of elastic link connected to it, okay? So that it is possible to, again, use a 4-bar mechanism in order to keep a hood open, for example. We have talked about these actually, I don't know. This is a lift platform again, and it's this is a microwave carrier, so that it takes a picture, a piece from one position and moves it to another position. So is this one. It takes the microwave oven and moves it towards here or somewhere around here. Okay, so this is a path generation mechanism. This is a crane actually, which generates straight line motion. The cranes are used, these cranes, you would see them in the harbors, in liman in Turkish, that is, in order to load ships with heavy loads. You have such loading cranes, and it is important, usually you hang a load from this point P, And it is important that that point P makes a straight line motion, because you don't want to rock the load so that it doesn't oscillate and so on. So we are concerned here only with the motion of this point P, and this point P has to make a straight line motion. And interestingly, with the appropriate design of the links 2, 3, and 4, with the giving them the correct dimensions, you can make point P move on a straight line, at least for a certain distance. Okay. Again, this is well, we don't have these screens. This was you remember that we had such computer screens. This is a computer screen that is here hiding inside the table. And then by a certain motion generation, it comes from storage position to the operating position, as you see the computer screen. And also, here you have, again, an object. This is its storage position. It might be a bed, for example. From its storage position to its active position, like this one, again with the help of a 4-bar mechanism, as you see. The 4-bar mechanism, as you see, is very, very useful for, well, for lots of applications. Again, you have a trash bin. Moved from one point to another one. It is moved from the floor up to the dump position. I guess this is for those trash trucks. They pick up a trash bin and convert it and put it inside the truck. The contents they dump the contents into the truck. I don't know why it does this sound. I copied it from somewhere else, but. And this is a boat is in the water. Again, a 4-bar mechanism takes the boat and lifts it out of the water with the help of this 4-bar mechanism. Straight line mechanisms. This is a 8-link mechanism. You have 8 links here, one being the ground. But the important thing is that point P makes a very straight line motion. It's called Purcell exact straight line linkage. This point P, as you see, makes an exact straight line. And this is a Chebyshev straight line linkage. This is a 4-bar linkage. So point P makes a straight line motion as links O2, 2, 3, and 4 move. This is a Watt straight line linkage. This is, again, makes an approximate straight line. This Watt is this James Watt, as you might remember, who invented the steam engine. By the way, these mechanisms were usually invented during the 19th century in order to, well, during the Industrial Revolution, in order to generate these motions for machines. For example, this Roberts straight line linkage has this point P moves in an approximate straight line. Another straight line linkage, in which this is the whole motion of point P. In this region, it moves in a straight line. On the rest, it doesn't move. It moves on something like an ellipse. But if this part is necessary for you, then you have a straight line. What is the AP value? Ahmed asks, what is the AP value? What does that mean? Which mechanism is that? Which mechanism are we talking about? p-value. On the slide we are looking. Well, the value, I have no, okay, that's what we need. For example, in this mechanism, the dimensions are, for example, for link 1, the distance is, let's say, 4. For link 2, the distance is 2. L3, the distance between A and B is 1. And L4 is 2. And AP is 0.5, which means that AP is in the middle of AB. Okay. So it just gives you the dimensions. What are they? They are might be in meters, they might be in centimeters, or they might be in inches. It doesn't matter. As long as the relative distances are like this, it's okay. Okay. The dimensions are given. It doesn't matter really. It's just these come out of the design like this. And if you simulate this, you can simulate this mechanism and find out that this is the result. Okay. And there is software to simulate those mechanisms, which I will, show you shortly, maybe next week or sometime. Okay. Again, another straight line mechanism. This one. Actually, it is the same thing as I have shown there. Again, this is a straight line mechanism. There was videos here, but I cannot show them to you. I guess I don't have them. No, but this is here. The straight line mechanism is used in the steam engine, for example, in order to make this piston go back and forth like this with the rotation. Rather, the piston goes back and forth and it converts the motion to a rotary motion, this mechanism. Okay. This is a Scott yoke mechanism, which is again commonly used. There is a video here, but I don't think I can run this. Maybe I can I? No, I cannot. This is a Geneva mechanism. I don't know again. Unfortunately, it doesn't run. But basically, the Geneva mechanism is a mechanism that is used in analog clocks. It is an intermittent motion mechanism. This yellow thing rotates continuously, and it engages with this green link, as you see, and makes it rotate for 90 degrees, and then it disengages, and then this whole thing makes one more rotation. It engages again with this green link. It makes it rotate 90 degrees again, and so on. So it is a intermittent motion mechanism. Geneva mechanism is, its importance is that it is used in the clocks. Just remember this one. This is a linear Geneva mechanism. Again, it is a mechanism that is used. There is a rotating cam here, and that cam is engages with the conveyor, and it pushes it for a while, and then it stops, and then it pushes it for a while again, so that the conveyor moves like this, stops, moves, stops, moves, stops, and so on. That kind of motion is generated by this linear Geneva mechanism. This is a ratchet mechanism, again used in the clocks. Okay. There is a wheel that is rotating, and these things are, actually, I don't know the details of this. Okay, this is a straight beam walking mechanism. Again, it pushes a conveyor, it seems to me, but it's a more sophisticated mechanism. And this is a simple mechanism actually. Two sliders and one connected by a rod. There was a name for this, but I forgot the name now. And then there are the cams. Cams are used in machines in order to generate certain functions. For example, in internal combustion engines, people used to use cams. I guess they are not used anymore, but they are used to generate a motion with a certain profile. So this is a cylindrical cam, for example, so that it generates a three-dimensional motion. And here you have a gear mechanism in which you have a rack and pinion. And then we will talk about gears later on. You have a worm gear, bevel gear, planetary gear. I guess you will talk about gears, how to design them in your machine elements class as well. But here we will look at the kinematics of gears. Okay, here you have a V8 engine in which there is an internal combustion engine, which is a slider crank mechanism connected to a crankshaft. And here you see that the valve for the piston is opened by a cam mechanism, opened and closed by a cam mechanism. As I have told you, this is how it used to work in the past, but cams are not used anymore. Instead, they are opened and closed by microprocessor operated devices. Okay. Okay. So these are cams and so on. Again, some gears, return rollers. Okay. Actually, this is more than I wanted to. There are certain mechanisms are like you have belts and so on. I don't know why it makes these sounds. I think this has become too complicated. Okay, I'll just. Okay, that's enough. So I will stop here. Do you have any questions?
Thank you, John.
That's not a question. Thank you. Let me just stop the recording.